In this lesson, we're going to be taking a look at the very last group of elements on the periodic table. Now, this group of elements is actually last in two different ways. First of all, it's the last group of elements because it's the farthest over to the right. It's also last because these were some of the very last elements to be discovered by chemists trying to isolate different elements from nature in their pure forms. You see, when scientists tried to isolate new, pure elements, they would try to take existing substances and then react them in some unique and creative way to yield a brand new pure substance. However, the noble gases have a characteristic that makes it very difficult to do that. In fact, impossible. You can't react substances to get the noble gases because the noble gases don't really react, especially as they're found in nature. So it's very difficult for scientists to discover these elements that we're going to be talking about today. The term noble gases actually implies that they are noble because they are completely unreactive. And that's what we're going to find is the key characteristic of noble gases. And we're also going to see how the structure of noble gases gives them that characteristic. As we begin learning about noble gases, let's first take a look at where they're located on the periodic table of elements. So far, we've gone through the different groups of the periodic table of elements and looked at the key characteristics and structure of each group. The noble gases are the group on the far right. So we're going to take a look at 5 of the elements that are noble gases by expanding the individual atoms and looking at what's going on inside them. So here we have helium, neon, argon, krypton, and xenon. And let's take a look inside these atoms and see what's going on that may explain why noble gases just aren't reactive. First of all, you may notice something about most of these atoms. Most of them have 8 electrons in their outer shell. If you count them up, you'll find that most of them have 8. Now, if you remember from the previous lesson, we learned something about that number 8. We learned that there's a number of electrons that atoms can have in their outer energy levels that makes them stable, electrically stable, and not likely to react with other substances. That number for most atoms is 8. However, for some atoms, like helium, helium is so small, it makes it a special atom. Whereas most atoms want 8 electrons in their outer energy level to be stable, helium actually only needs 2. Its outer energy level isn't even big enough to accommodate 8 electrons. So for the smaller elements, hydrogen, helium, lithium, beryllium, and boron, 2 electrons in their outer energy levels makes them completely stable and unreactive. So because these atoms have full outer energy levels and are stable, they're not going to form ions at all, and because they're not going to form ions, they're not going to react with other substances in that way. They have no need to chemically react with other substances because they have stability. Also, because of that, these substances are typically found in nature in their pure atomic form. Oftentimes, we find them mixed together with other gases, but they're definitely not bonded to atoms of those other substances because the noble gases just don't make chemical bonds with other substances. And you'll see that that concept dominates their characteristics as well. First characteristic, they are completely unreactive. They just don't form bonds with other atoms. Because they're so unreactive, they don't even like to stick together with each other. So these substances have extremely low melting and boiling points. They're gases at room temperature because it takes such low temperatures to condense them to a liquid or freeze them into a solid. Because the noble gases are so stable, they just don't like to come together in that way. And then finally, noble gases have the same basic properties that all nonmetals have. They are terrible conductors of heat and electricity. You can't pound them into flat sheets because obviously they're gases at room temperature. But even if you were to freeze them into a solid, that solid would be very brittle and you'd be able to shatter it. The noble gases typically have very, very low densities for elements on the periodic table because the atoms don't come very close together like they do with metals. So the key characteristic that dominates all of our discussion about noble gases, because they have an electrically stable arrangement of electrons on the outside, they are completely unreactive substances in nature.